kubeadm. But building a cluster is just a beginning. Like any powerful system, it's required ongoing care and maintenance to keep it healthy, secure, and updated. In this topic, we are going to cover safe process for upgrading your cluster to a new Kubernetes version. Why do you need upgrades? The Kubernetes community releases new minor versions roughly every 4 months, packed with a new feature, performance improvement, and crucial security patches. Staying current is the key to running a healthy cluster. These are general recommendations applicable to all Kubernetes distribution, including Kube, Spray, kubeadm, and Rancher IKE2. Upgrading Kubernetes, unlike any initial installation, is a deliberate process that must be done according to specific rules to ensure that the cluster remains in healthy state and avoid any inconsistency. Before beginning, it's essential to have a backup of etcd. This provides a critical rollback path to the previous version in a worst case scenario. I'll talk more about etcd backup later. There is also golden rule for upgrade. You must upgrade one minor version at a time. For example, you can upgrade from 1.18 to 1.19, but you cannot jump directly from 1.18 to 1.20. Attempting to skip minor version is unsupported and will very likely break your cluster. The overall process is methodical. It's designed to prevent downtime. We always upgrade the control plane nodes first, one at a time. And then we upgrade worker nodes also one at a time. Let's begin. I'm going to SSH into the control plane node. Okay, I'm already in the control plane node. So let's get the baseline of our cluster current state with kubectl get nodes. And as you can see, both of our nodes are currently running version of 133.5. Our goal is to upgrade them to version 134.1. To illustrate the upgrade process, I utilize the Debian repository of 1.33 stable version, as the most current Kubernetes version available is 1.34.1. So the first step is always to upgrade the kubeadm. This is the orchestrator of upgrade, so it needs to be the newer version first. On Debian, we can use apt to find and install the specific version we want after changing the source to latest version. So I can show you that what kind of version we have at the moment. This is like 1.33.5. This is the latest packet apt version we have. But to change this, we need to change the sources of. So we'll change this line to version 1.34, and then now we do the apt-get upgrade or apt update. It will update the source list. Okay. And then let's unhold if we lock the version of Kubernetes. It's recommended to lock the version of production environment to avoid any unattended upgrade on OS level. So I'm checking first that if we have any hold for this packet. I'm using the show hold to see that is there any hold. Apt mark show hold. Okay, there is no hold at the moment, so I can use the medicine to check what kind of version. Right now, you can see that the version 1.34 is available to upgrade. So the next step is just to installing the kubeadm, the latest version. And now we can see that it's upgrading and kubeadm is upgraded. Next step into upgrading our cluster is, now that we have new kubeadm, we can use it to plan the upgrade. This is crucial dry run setup. So run this. This command checks the health of your cluster and tell you exactly what changes it's about to make. It's your chance to review everything before committing. So now it's the plan looks good. So let's apply it. This is the main event for the control plane. Okay, let's copy the line kubeadm upgrade apply version 134.1. And this is going to upgrade our control plane. So this is asking me that, are you sure? And I say yes. This process usually take up to 5 minutes. So meanwhile, we can see what is happening on the screen. So kubeadm now upgrading the static pods manifest on the API server, control manager, scheduler, and etcd. It will bring them down and start them back up with the new container images. This can take a few minutes. So let's wait for a couple of minutes until the cluster gets ready. The reason why this is taking like 5 minutes is because it needs to stop the containers like controller, scheduler, etcd, and API server, and downloading the other images from the internet, and then starting the latest version. So and I'm checking the health checks, of course. That's also important part after running the new version of Kubernetes. Otherwise, we will have a broken cluster. Okay, as you can see, this is going to be good. So we're waiting for kubelet to restart the components. So at the moment, we are only upgrading the server components. So the kubelet is not upgrading, and it should be upgraded separately. In the next in the next step, we are going to upgrade the kubelet as well. So I can show you where we can see or where we can find out that the server is in a newer version. Okay, I'm still waiting for this process to finish. But basically, the next step is draining the node. And I'll talk about that more. Why we need to drain the nodes before upgrade, and that's very crucial step in upgrading the Kubernetes clusters. So let's wait a bit more for cluster to be ready. Okay, and then controller manager is the next one. And that should be the last part. And queue scheduler. Okay, now it seems that everything upgraded as we expected. So if I'm showing you K version, which is like my kubectl version, it's showing me that the server version is 1.34.1 and client version is 133.5, which is my kubectl version. But if I'm getting the nodes, you can see that here on the version side, it's still showing me that the control plane is version 132.5. This version is a kubelet version. To upgrade the kubelet version, we need to first drain the node. What Once that's done, we need to prepare the node for its own package upgrade on kubelet. We do this by draining it, which safely evicts all of the application pods. It's important to remember that this specific setup, we are working with a single controller. However, in production environment, you should typically have multiple controller. In such real-world scenario, the drain process becomes crucial for preventing any unnecessary downtime for your workload. So right now, as you can see, I have only one control plane node, but if we had more than one, then we wanted to these pods to go to the node 2 instead of staying at the node 1. So evict, just kicking the pods to go and find another node. So I'm going to drain the node. So it's drained. The ignore daemon set flag is important because daemon set pods are meant to run on every single node, and we need to tell drain to leave them alone. Otherwise, without the ignore daemon set, the drain will fail. The drain command offers various flags that can be adjusted to suit different environment and situation. I'll recommend you visiting the official drain documentation in Kubernetes website for further details. So final two components, the kubelet agent and the kubectl command line. So we are going to do the same thing on hold everything that we set for kubelet, and so as you can see we don't have any hold for them. And then we are going to install the latest version of the kubelet and kubectl. So this will downloading them from internet, and then we create another hold for kubelet and kubectl to make sure that this unattended upgrades they are not affecting these two. So after upgrading the kubelet, the only remaining thing is to restarting the kubelet. This will make sure that we are getting the latest version. So if I'm now get the nodes, you can see that the scheduling is disabled. It's because the node is drained, but the version is 1.34.1. So finally we uncordon the node, which make it schedulable again, allowing to accept the new workloads. So the cordon is uncorded, and then you can see it's the status is ready and it's accepting new pods. So let's check our nodes again. As you can see, these two are ready. Perfect. The control plane now is version 1.34.1, while our worker is still old version. Now let's upgrade the worker. The process for the worker is very similar, but a bit simpler. I'll SSH into the kube controller worker. So first step is to upgrading the kubeadm, of course. So I'm going to change the pack apt version. Okay. So apt get update. Then I'll unhold the kubeadm if there are any hold. And then I'll upgrade it to the latest version of kubeadm. So for worker node, we don't apply an upgrade. Instead, we run a special command that pulls down the latest configuration from already upgraded control plane. So I'm going to use this. So the next step is to draining the worker. So I'm going back to controller, and then I'll drain the worker 01. As you can see, it's evicting the Calico kube controller and the core DNS, which we were running on the node. So the next process is upgrading the kubelet on the worker node. So I'm going back again to the worker node. I already updated the. So I want to remove hold for kubelet. There is no hold. And then I will update the latest version of the kubelet, which is 1.34.1. And then in the end, I will create a hold to make sure that we are not upgrading the node unintentionally. And then I'll reload the daemon set and restart the kubelet. Now, if I go back again to the controller node and get the nodes, you can see that the controller and worker both are version 34.1. The next step is to uncordon the worker node. So by this way, we make sure that both nodes are able to schedule. So and there we have it. Both nodes are successfully running version 1.34.1. We completed a safe rolling upgrade for our cluster. Thank you for listening. In next topic, we are going to cover etc snapshot and restoration.